Okay, we're going to go through with using the rational root theorem and synthetic division to factor out polynomials. So we're going to start out with this polynomial here. So using the rational root theorem, what that tells me is I want to take all the factors of my constant term, which we call p, so you notice I'm writing out factors of constant term. We refer to this as p. So I'm going to look at my constant term here, and I have 5 for a constant term. Okay, it's pretty easy. The only factors of 5 are 1 and 5. Luckily, we picked an easy one, but like say it was 6, then you'd have to write out 1, 6, 2, and 3. Those would be all the factors, and so on. You would do that based on your constant term. Now next, I'm going to go to the coefficient of my highest degree, what we call the lead coefficient. We've been using that before. So my lead coefficient here is 5. So I want the factors of my lead coefficient. And again, my factors are 1 and 5. So what do I do from here? What I do is I'm going to divide the factors of my constant term by my lead coefficient. So I would take 1, my possible roots are all going to be p over q, all the p's over all the q's. So in this case, it would be I could have 1 over 5, that's going to be positive or negative, or I could have 1 over 1, positive or negative. And then I would go the other way around too. I could have 5 over 1, positive or negative again. And then I could also have 5 over 5, positive or negative. So if I simplify these out, you'll notice that 1 repeats itself. 1 and 1. So really I have 3 possible factors here, or 3 possible roots. Actually, I have more than that, and you'll see what I mean in a moment. And then I have positive or negative 5. These are all my possible roots. So technically, my possible roots could be negative 1/5 and positive 1/5. I could have positive 1, I could have negative 1. And I could have positive 5, and I could have negative 5. So I have 6 possible roots. Now I know since my degree is 3, I only have 3 roots, which means 3 of these aren't going to work, and 3 are. So it's a matter of figuring out what your roots are. One way you can do that, we've talked about this, you can set up your whole polynomial to equal 0. You can do 2x squared plus 19x minus 5 equals 0. And then you would have to plug in every single value. So I'd start with negative 1/5. Okay, plug that in for x. Do out the whole thing. See if I get an answer of 0. Then I would have to go and plug in 1/5. Do out the whole equation. See if I get an answer of 0. What I mean by that is because someone asked, I'd have to literally plug in all these values for x. One-fifth minus 5 equals 0. So I'd have to do out this entire thing and then hope at the end that I get an answer of 0 equals 0. If that happens, then that's a root. If I don't get that, then that means whatever I plugged in is not a root. I would have to do that for 6 cases here. That's a lot of math, and you don't have to go that route. One way you can do this is using synthetic division, which I'm going to show you. So I'm just going to shrink this stuff down here, the stuff I did with my rational roots, my rational root theorem. So what I can do now is I'm going to try one of these. I'm going to go with 1. You know why? Because it's easy. When possible, go with something. So I'm going to try 1 first. Here's how you would use synthetic division. All right, I'm going to start with 1. I'm going to kind of box it up here. I'm now going to write out all my coefficients within my polynomial as well as my constant term. My coefficients are 5, 29, 19, and negative 5 would be that constant term right here, negative 5. All right, and this is how synthetic division works. All right, I'm going to draw a line. I'm going to drop down my 5. I'm going to drop it on down. I would then do 5 times 1. I get 5. Bring it over here. 29 plus 5 gives me 34. See, 34 times 1 gives me 34. 19 plus 34 gives me 53. 53 times 1 gives me 53. And then I would do negative 5 plus 53, which gives me an answer of positive 48. What does that mean? This would technically be my remainder. This is not 0. We want it to equal 0. Since this is not 0, what that tells me is 1 is not a root. Okay? So we know 1's not a root. Let's try another one here. Let's try, I'm going to go with positive. I'm going to go with negative 5 this time. We'll try negative 5, see if that works. So again, it's the same process. Box up my 5. And I'm going to write out those coefficients and the constant term. 5, 29, 19, negative 5. All right, let's do this out. So I'm going to draw my line. Start by dropping down the 5. 5 times 5 gives me 25. 29 plus 25 gives me 54. 54 times 5, it's getting messy, but we can handle this. 270. 270 plus 19 gives me 289. 289 times 5, I'm getting something big now. I believe that would give me 1,445. Now, when I do this out, I know I'm not going to get 0. This is not 0, so guess what? I found something else that is not a root. So I'm narrowing down my choices now. I know I have 3 roots. I know one of them's not 1. I know one of them's not negative 5. Let's try another one here. I'm going to try positive 5 this time. Oh, actually, I did try positive 5. Whoops. No biggie. I'll try negative 5 this time. Let's try negative 5. Let's see if that works. So again, it's the same process. Negative 5. I'm going to write down my coefficients again and my constant term. 5, 29, 19, and negative 5. All right. Drop down my 5. 5 times negative 5 gives me negative 25. 29 minus 25 or plus negative 25 gives me 4. 4 times negative 5 gives me negative 20. 19 minus 20 gives me negative 1. Negative 1 times negative 5 gives me positive 5. And negative 5 plus 5 gives me 0. Guess what? That's what I want to get here. So I like 0. My students give me a hard time because I like to put the exclamation points. Because now I know negative 5 is a root. So I found one of my roots. There are 3 roots in this problem. I found one of them. So what you could do is you could do out the rest of them using synthetic division. However, here's a nice way to get those final 2 roots. Once you find one, right? We started out with x to the 3rd, right? Since we've factored this out a bit, this is what we're left with. 5x squared plus 4x minus 1. I'm going to set this to equal 0, and then I'm going to factor this out. I can use the AC method, which means, let's see, a times c equals negative 5, because again, I'm multiplying 5, negative 1, that's a times c. I know b is positive 4. And now I want to think of 2 factors of negative 5 that give me positive 4. That would be 5 and negative 1. So I'm going to use my box method now, as we've done in here. I'm going to go with, let's see, 4 terms. I have 5x squared here. I know that 5x is a factor. And I also notice that negative 1. So as we said, when we did it out, we knew that 5 and negative 1, that gives me b. I like that. and negative 1. And then what I do is I just factor this out. 5x going across again, I can factor out negative 1. Then I go horizontally. 5x squared and negative 1x, I can factor out x. And then 5x and negative 1, I can factor out 1. So if I factor out my polynomial now, I get 5x minus 1, then x plus 1. And now to figure out my roots, all I got to do is set them to each equal 0. 5x minus 1 equals 0. X plus 1 equals 0. And then if I do out my math, I realize I get x equals 1/5. I also notice that I get x equals negative 1. Guess what? I found my other two roots. And let's see, were those some of the possibilities I started out with? I believe they are. 1/5 and negative 1. Going up to that rational root theorem. 1/5, yup, and negative 1. I found my three factors. So that's how you can use synthetic division to find the roots of a polynomial that you can't factor easily. Now, people mention sometimes you can graph them. That's cool. But the thing is, if you graph this, it might be hard to see that 1/5 because you really have to break that the graph up into smaller values, because you typically just look for when it passes through a whole number, right? When you graph something, like especially if this is cubed, you know it's going to look something like this. 1, 2, oh, it's not going to look like that, excuse me. Let's see, it goes up once. There we go, 1, 2, 3. It's probably going to look something like that. I'm just making it up. But if you get 1/5 as one of those values, it's going to be kind of hard to see. So that's why that's why it's not easy to just always graph them. You want to figure out what those roots actually are. So that's how you can use synthetic division in the rational root theorem to factor out a polynomial. Now, primarily, you're going to be working with synthetic division in here. You'll be given roots to try. And sometimes you might have to use the rational root theorem to figure out what roots. So we're going to do one example here where I did one using the rational root theorem. I'm going to give you a synthetic division problem where you are trying out a factor, trying out a root to see if it works. So let's try. Let's see. I got an example right here. We're going to go with y to the fourth, 8y to the third, plus 10y squared, plus 2y, plus 4. And what we're trying to see is if we could factor out y minus 2. Now remember, when we're talking about roots, we're talking about it being in intercept form. It's always a variable minus something. So the root we would be trying here would be 2. So let's set this up. So I'm going to go with 2. And then I'm going to look at my coefficients. My first coefficient here, I don't have anything, so I'm going to go with a 1. My second coefficient, I got a negative 8. My third, I've got positive 10. My fourth, I've got 2. And then we go with that constant term with a 4. And let's see what happens. We're going to try positive 2, see if it's a root. So I'm going to draw my line. I'm going to drop down the 1. 1 times 2 gives me 2. Negative 8 plus 2 gives me negative 6. Negative 6 times negative 2 gives me negative 12. 10 plus negative 12 gives me negative 2. Negative 2 times 2 gives me negative 4. 2 minus 4 gives me negative 2. Negative 2 times 2 gives me negative 4. 4 plus negative 4 gives me 0. That's awesome. I like seeing that because what that tells me is 2 is a root. Now I could try here too if I wanted to. I could try some other roots. But ultimately, you just want to be able to try a root out on a polynomial and see if it works using synthetic division. Hopefully this gives you a little bit of guidance into how to do these, especially if you have to use the rational root theorem first. Again, that can give you a lot of possibilities. So it's good to be able to try one and then be able to factor it like we did in the first one here, where we were able to find a root, and then based on that, we were able to factor that remaining polynomial. But ultimately, remember, try a root, go with the coefficients and your constant term using synthetic division. Drop down the first term, then just multiply this times this, add it, multiply this and this, add it, multiply this and this, add it, and then at the end, you want to get 0.